Hello, I want to take this opportunity to welcome you back to our class once again. Today we are looking at contour, a topic known as surface area of solids, as a topic which is surface area of a right pyramid cluster. Example, the diagram below shows a right pyramid cluster whose dimensions are given as shown. Find its total surface area. We are talking about dimensions. This is the cluster we are talking about. The top is a rectangle measuring 40 by 20. The bottom is also a rectangle measuring 25, 10, and the vertical height is 60 centimeters. That particular cluster is represented by this grid. From the start, it is upside down, but if we change it in such a way that the bottom becomes the top and the top becomes the bottom, we will obtain something like this, whereby this will be A, B, C, D as our base. Our top will be F, E, H, G as shown in the other diagram here. So this is a cluster, meaning that it was cut from a full pyramid. So if we extend this particular slant height, we also extend this line, we extend this other line, we extend this line, we will obtain a full pyramid which looks like this. So this is represented by that diagram that I've already drawn for you. At this given point where the slant heights will meet, I've called it V. Now, the question here is finding the surface area of that particular figure. For us to be able to find the surface area, remember the top is a rectangle, the bottom is also a rectangle. We will determine the areas of those two rectangles. Then we add with the curved surface area. This is curved surface area, curved surface area, curved surface area, curved surface area. But when you look at this grid, this becomes a trapezium. But in this case, we will use a concept of area of a triangle. Because once we extend this side, we obtain a large triangle, namely VBA. So if we determine the area of this triangle, which is VBA, then we subtract the area of the smaller triangle, which is VGF. We can obtain the area of GFAB. That's what I've indicated here. That to obtain area of BGFA is equal to area of EBC, which is on the opposite side. Opposite faces are equal in this particular case. But the area itself is found by taking the area of triangle VBA minus this smaller triangle VGF. The same case applies to this other face, which is also a triangle VAB. To get the area of AFED, which is equivalent to the opposite face, which is BGHC, we will find the area of VAB, which is a triangle. Then we subtract the area of the smaller triangle, which is VFE, represented by this particular grid. I'm talking about VBA, VGF. So this point here, I've called it midpoint M1, small. This is capital M1, represent the midpoint of VA down here. So we need this. We need the length of V M1 small, then V M capital 1 down here. So I've just extracted this particular right angled triangle V T small, then M1. This is V T small M1, which is V T small M1. I've already gone down from V to capital T, then M1. I've extracted V, T, capital and M1 here, so that we can be able to get all of it of this slant length, which is represented by capital L1. Then to get this smaller one, I've taken it to be represented by small L1. So we will apply Pythagoras theorem. So now let's find L1. So we will say L1 is equal to the square root of 60 plus 5, both of them being square. This will give us 3,600, then plus 25. So when you add 3,600 plus 25, you get 3,625. So the square root of 3,625 is 60.21 centimeters. Let's find L1, which is the same as the square root of 120 square plus 10 square, which is equivalent to 14,400, then plus 100. So when you add these two, you get 14,500. So what is the square root of 14,500? You get 121, 120, you get 120.42 centimeters. So that's how we obtain L capital 1, L small, L1. Now from there, we need to come down here. That goes for this face. For this other face, I've taken L2 small to represent VM2 small, then VM capital 2 is represented by capital L2, as you can be able to see here. Now let's find L2 small, L2 capital. So using Pythagoras theorem, so L2 is equal to the square root of 60 square plus 10 square. So which gives us 3,600, then plus 100. Okay? So how much do we get? This gives us 3,700. The square root of 3,700 becomes 60.83 centimeters. So on the other side, let's find capital L2. L2 is equal to square root of 120 square, 20 square, which gives us 14,400, then plus 400. So when we add the two, we get 14,800. So the square root of 14,800 becomes 121.66 centimeters. So this L2 small L2 capital represents this other face. This other face is represented by L1 small and L1 capital, as you can be able to see. So we need to find this area here using this concept. So that's where we are going to. Let's find the area of BGFA. Which is the same as the area of the larger triangle, VPA, which is a half times the base is 40, 20 plus 20. Then the height, the one that we have found as L1, is 120.42. Then we subtract a half times the smaller triangle, which is base is 20, then times the height, which has been represented by L1, so which is 60.21. So 2 comes here once, goes here 20, 2 once, goes here 10 times. So we take 20, we multiply by 120.42, so we get 2408.4. This one gives us 602.1. So when we subtract, we will get 1,806.3 centimeters squared. So that's the area of BGFA. Let's find the area of FA DE. now represented by this other face, VAD. So we will now take that as a half times the base is 20, 10 plus 10. The height is represented by capital L2, which we got as 121.66, then minus a half times the smaller one, VFE. This base here is 10. 10 times the height L2 small, represented by 60.83. So 2 comes here once, goes here 10 times. 2 comes here once, goes here 5 times. So we will have 1,216.6. Then we subtract 60.83 times 5, which is 304.15. So when we subtract 1,216.6, we will get 920.45 centimeters squared. There's something we noted here that BGFA is equal to EBCH. What I mean is this face is equivalent to this other face. So the area we have obtained for this face will be multiplied by 2 because this face is equivalent to this. The area we have found for this face, we are going to multiply it by 2 because this face is also equivalent to the opposite face. Now, our total surface area will be the area of these 4 faces plus the area of the base plus the area of the top. So total surface area becomes is equals to the first area that we obtained, which is 18.3 times 2 because we have another face. Then we add 912.45, we multiply by 2 times another opposite face which is equivalent. Then we add the area of the top, which is 20 times 10. Then we add the area of the base, which is 40 times 20. So now, using our calculator, we will now obtain 1806.3 times 2. We will obtain 3612.6. We add 912.45 times 2. We get 1824.9 plus 200, then plus 800. So total becomes 3612.6. We add 1824.9 plus 200 plus 1 plus 800. That gives us 6,407.5 centimeters squared. So that's how we get the total surface area of the pyramid, which was just like this. Then we turned it upside down. Then we extended to obtain a larger pyramid. God bless you. Thank you for listening to me. I'm so thankful. Kindly keep supporting us by viewing and subscribing, at the same time sharing. God bless you. See you next time.